As we proceed through the 2011 NORCA membrane roof systems manual, we're not going to highlight anything out of Chapter 2 air and vapor retarders with regard to the flat roof, or once again low slope is probably a better term. We're not going to highlight anything, but be aware that it is here and there is a chance, there's always a chance that they'll develop a test question for us. So we're going to concentrate on page 41, chapter 3, where we have seen lots of questions. This is about roof insulation. They call it rigid board insulation. Roof insulation that is properly manufactured and designed, second paragraph, and installed serves several vital purposes. And you can go ahead and highlight all those and kind of take a look at those if you like. You can pause the video and read through those. It's pretty self-explanatory. It does tell us on page 42, same type of thing, left-hand column about halfway down, the desirable properties of roof insulation, and you can once again kind of peruse through that at your leisure. The types of roof insulation on page 42, right-hand column, are all here. Here's all the different types of roof insulation that are going to be discussed in this manual. And you can find them here, and you can find them in a little table of contents too. So make sure that they're, you can locate them. The following criteria, left-hand column on page 43, should be considered by designers on steel roof decks. The steel deck's flutes, direction, rigid board insulation, orientation, and membrane layout should be designed to accommodate the satisfactory anchorage of a roof system components. Next paragraph on steel roof decks. Rigid insulation boards, if rectangular, should be placed with their longer dimension edges supported on the top flanges of the steel roof deck. Second to the last bullet in that left-hand column, on low slope membrane roof system construction, use of 2 or more layers of rigid board insulation is preferred. The board joints in the second layer of rigid board insulation should be offset from the joints in the first layer to reduce thermal losses and reduce membrane stress. We're told that at the top of page 43 there was a paper done called the Thermal Evaluation of Effects of Gaps Between Adjacent Roof Insulation. Alright, and what it basically says is it's shown that a minimum of 2 layers of rigid insulation can provide the following benefits. Basically, if you use 2 layers of insulation, you can separate the joints, you can stagger the joints. And it tells you, 1, 2, look at the bullets, better performance, less thermal loss, reduced bridging, thermal bridging, and reduces the tension on the top of page 44 on the left-hand column for membrane buckling, ridging, and splitting. Let's look. There's some formulas here that might rock your world under principles of thermal insulation. You may be asked to figure out the K value. Well, the best thing to do is just open up the book. You don't really have to understand this stuff. All you got to do is just punch in the numbers. If they ask you the K value, okay, which is thermal conductivity, you're going to take whatever the BTU rating is for that material, 4, 5, 6, whatever it is, times the inches, the thickness of it, and then you're going to divide that by what type of square footage we're talking about. If they just want per square foot, that number will be 1. How many hours we're talking about, okay, if maybe that'd be 1 if it's per hour, and then the temperature degree change in Fahrenheit. So there you go. And all you got to do is just punch that information they give you in, and you'll get the thermal conductivity. The thermal conductance, okay, it says it's similar. It's a unit of heat flow, but it considers the thickness of a material. So then what you have to do is you have to take the K value over the thickness in inches, and then you get the thermal conductance. All right. Then we got thermal resistance. Okay, the R value equals 1 over C. So if you have the C, all you got to do is just take 1, divide the C into 1, you get the R. The equation for determining a material's total R value, all right, is R equals 1 over C, or the total R value equals the thickness divided by the K. To find the R value of 1 inch of material, it's 1 over K. The overall coefficient of thermal transmission is a unit of heat flow for a complete construction, including all associated air films, air spaces, and materials in the assembly. It is calculated by taking the reciprocal of the total of the resistances of the various elements of the assembly. So the U value, which is the coefficient of thermal transmission, U, you take all the R values of all of the materials in a system, in a roof system, and you add them together and you divide them into 1 and you'll get the U value. Now they may make it real simple. They'll give you the R value and you just have to pull the U value off this table or vice versa. That's a good way to do it. Hopefully they'll do that for you. Otherwise you may have to do a little bit of math. On the next page, it talks about, this is what they're doing on page 47 on the left-hand column. Here's all the different components, and you add them all up. You've got a heating and a cooling, all right, depending on, because a material has a different heating R value than a cooling R value many times. So you have to add all those up, and then you get a number of the total R, RT. And then you take the RT and you get the reciprocal of it. But look what they did here. That's the U value. They have R equals 1 over RT. I think that's wrong. That should be U equals 1 over RT. All right. And then it says, in this example, RT for heating conditions, R total for heating conditions, was used for determining the assembly's overall coefficient of thermal transmission, U. See, because it results in the most conservative value. There you go. All right, guidelines applicable to all insulation types. When double layer insulation is used, all the joints of the insulation boards in the top layer should be offset from the joints in the underlying layer a minimum of 6 inches. All right, now we're going to go to section 3.2, which is about cellular glass. So this is a specific type of insulation, rigid board insulation. It's called cellular glass. And here's all the things it does. All right, there you go. And here is the design standard. And here's the R value per inch, 3.44 R per inch. Tested at a 75 degrees. They may ask you that, you know. It's 3.44 at what temperature? Well, 75. Board sizes and thicknesses. Well, there it is right there. If you get the question about, you know, what size it comes in, well, there it is. Okay. It's available in 2 by 4 foot board sizes. Usage guide, multi-layer insulation. This is important. When the total required thickness of the cellular glass insulation is 3 inches or greater, NARCA recommends designers specify cellular glass insulation as multiple layers. You're going to see that in a lot. This is important. You're going to see this in several of our types of insulation. Let's look at expanded polystyrene, EPS. Okay, look at all the attributes, the aspects of EPS, and look at those and highlight them. Sure. We're told that on the left-hand column on page 50, let's read this whole paragraph. Expanded polystyrene insulation should not be confused with extruded polystyrene insulation. Both products are based on a polystyrene polymer, but each has specific advantages and disadvantages. Typically, expanded polystyrene insulation is produced in a wider variety of densities, thicknesses, and R values, but is more sensitive to ultraviolet degradation and moisture absorption under certain conditions. Extruded polystyrene insulation is more weather resistant and is used in protected membrane and green roof systems where insulation is not covered by the roof membrane. The product standard for expanded polystyrene, there it is, C578. Here's our value, and this says expended, it should say expanded. All the different types, all the densities, and the compressive strength. Okay. Once again, there's our R value, board sizes and thicknesses, usage guidelines. It talks about a multi-layer insulation, but it doesn't give you an actual thickness there. So you might want to just keep that in mind. Let's go to the next page, page 52. We're discussing extruded polystyrene here. We're told here's what it does. All these things. These are all the properties of it. Okay, great. Here is the product standard, the C578. The R value on page 53, 3.9 to 5.0. Your board sizes. Okay, this is the size it comes in, and the usage guidelines. It does talk about a multi-layer, but it doesn't give us a thickness again. It just says it can be used as part of a multi-layer system. Let's look at faced gypsum over here on page 55. Two types, okay, of faced gypsum. Faced, paper faced, and glass faced. And here's all the things that great faced gypsum does. The design standard at the bottom, 1396 on page 55. And we'll go to the next page and it tells us our R value. Faced gypsum has R values. Here's our thicknesses and here's the R value. Here's the board sizes, left-hand column, halfway down, the size you can get it in. Fiber reinforced gypsum on page 57. So this is not faced gypsum, this is fiber reinforced gypsum. This is a different type of insulation. Here's what it does, all its properties. Here's the design standard, 1278. We flip over, we see a table, it says faced gypsum. Guess what? That's fiber reinforced gypsum. That's another editing error. This book is starting to scare me a little bit. We have all of our thicknesses and we have all of our R values. We have our board sizes and thicknesses that's available in and our usage guidelines. Okay, it does talk about multi-layer, but it doesn't give us a specific number of inches. Another type of insulation is mineral fiber. Okay, here's what it does. Those are our properties. Here's our design standard, page 59, top right. There's our R value. Okay, the common R value is 4 per inch of thickness at a density of about 10 pounds per cubic foot. Your board sizes, your usage guidelines, and they give us a number here, so you might need to pull out that 1.5 on that multi-layer insulation issue. Let's go to the next page. Page 60, we're talking about perlite. Right-hand column at the top, about 4 lines down. The common R value used to calculate the total resistance of perlite is 2.78 per inch. All the things that perlite is all about right there. Bitumen and adhesive compatibility, component compatibility, impact resistance, pretty much a standard list. Product standard is C728. Once again, we go to the table on page 61. Guess what they did to us again? They said this was faced gypsum. It's really perlite. All right? And it gives us our R values. Board sizes and thickness, usage guidelines, multi-layer insulation doesn't give us a number, but it can be used as multiple layer. Page 62, another type, polyisocyanurate. As we go down, we see all the different bullets, the ISO board, what it does. Okay. The product standard is 1289. We have an R value. Okay, good R value. Top right, when designers use the polyisocyanurate insulation, NARCA recommends they determine their thermal calculations using a service R value of 5 for heating and 5.6 for cooling. So make sure that if a R value is one thing, service R value can be another thing on the test. So be aware of that. Polyisocyanurate, well, at least they got the name of the table, the heading of the table right. You got your thicknesses and you have the R values. Make sure you can find that. Okay, it also talks about something called LTTR. And if you go up here, it'll tell you what LTTR is. It's the long-term thermal resistance. That's left-hand column on page 63. Long-term thermal resistance. Board sizes and thicknesses, and then the usage guidelines. And it gives us a number under multiple layer insulation, multi-layer, and that's 2 inches. Okay, so read that. Be familiar with it. High-density polyisocyanurate, all the things it does, the product standard, the R value, the board sizes. Okay, there you go. Wood fiber board, left-hand column at the bottom. All of the attributes of it. The ASTM design standard in the right-hand column is C208. It comes in 3 different forms, plain, coated, and impregnated with asphalt. It's got an R value of 2.78 per inch. It has board sizes here and the usage guidelines, and look at there, it does have a number here for the wood fiber board. So if you're going to put more than 1.5 inches down, you better believe it, you better have 2 layers. Now those are all the different types of insulation. Now when you go to tapered insulation, the way they have it edited, it almost makes it seem like it's just another type of insulation, but it's different. What that means is it's thicker on one end and thinner on the other. Well, what does that do? Well, that, you know what it does. It creates slope. So you've got your, your steel decking or something along those lines. It's completely flat, and you have to create some drainage, so you have tapered insulation. Well, most of these types of products come in a tapered form. Tapered insulation can be used to meet the requirements for slope in new construction and re-roofing projects, as well as in cases where a roof deck will not provide adequate slope to drain water off a roof surface. For new construction, most model building codes and most local building codes require a minimum of 1/4 of an inch and 12 inches roof slope for all low slope assemblies except coal tar, which requires a minimum of 1/8 and 12. Let's go to the next page, page 69. This is determining R value. All right, as you read through this, you might want to spend some time reading this. We're told there's 2 common industry approaches. You can figure a roof based on its minimum R value, or you can figure a roof based on its average R value. The minimum R value, all that means is whatever the minimum thickness, like around the edges is, that's what you're going to use as the R value. It says it's a conservative approach, okay? It says that right here. It's appropriate to use the R value approach for determining the R value of a tapered insulation system when a conservative thermal efficiency design is desired, okay? Or when determining the necessary minimum thickness of thermal insulation above a vapor retarder to prevent condensation. That's one way, two instances in which you should use the minimum. Now the average R value approach establishes the thermal resistance for a tapered roof system by determining the R value in the tapered material at the representative average thickness. So what you should be able to take, if you have 8 here and 4 here, you should be able to add 8 plus 4 divided by 2 and you get 6, right? That's the arithmetic average thickness. And then however many inches that is, you multiply that times the R value per inch of the material. Now, if you go down, if you look at the way they have this formula here, it's fairly convoluted. It says you take the LP plus half the HP minus the LP, and that's the way they want you to do it. Well, let's look down here. I've done that for you. 4 plus 1/2 of 8 minus 4. It's 4 plus 2. You still get 6. All right. You can work it out both ways if you want to on test day. You might want to do it the way they tell you to, but you should get the same answer regardless for the arithmetic average. Now, the volumetric average is different, so watch for that. Volumetric average. Look at this diagram here. This is the arithmetic average on page 69, this diagram. Basically, you just hit the halfway point, and boom, there you are. Now, on the volumetric, we're on page 70 now, thickness. Because there's so much more insulation here than there is here, to get a volumetric average thickness, you're actually in a thicker area. Alright, so here is the formula for the volumetric average thickness. The LP plus 2/3 times the difference between the HP and the LP. High point and low point is what that means. And I've worked that out for you. Same roof, 8 and 4, 8 on the thicker, 4 on the thinner, 4 plus 2/3 times 8 minus 4, you work that all out and you'll get 6.67. So the difference between the volumetric and the arithmetic is going to be different. Wow. Now, on page 71, the types of tapered roof insulation, all these types of rigid insulation board come in tapered as well to create your slope. And on page 72 and 73, they give you all these different diagrams of how you create slope and so forth. You can take a look at those. Nothing really earth-shattering in that. And as you go to the next page, on page 74, you might have to put some saddles. All right, you've got your roof slope, your saddle material slope, and your ratio. These are your recommended length to width ratios for saddles and crickets. So if you get a question about that, there they are. And it shows you how you can use saddles and crickets on a low slope roof to create slope. So you might want to take a look at those diagrams there. That's about it. The next section is going to be chapter 4, roof membranes. But that's a lot of information. You might want to watch this one again, especially the decks, the insulation, and the membranes. This is an important, very important book to get familiar with.